Okay, so let us try to understand how to find out the solution of this second order differential equation. Suppose we are given over here that we are having d2y by dx square plus y is equal to 0 as our second order differential equation, and we have to find out the solution for this with the conditions which are given as y is equal to 2 for x is equal to 0, and when x is equal to pi by 2 the value of y is equal to minus 2. Now let us assume that this d by dx is equal to capital D. So this is known as the D operator. So d2 by dx square will be d square y. So d square y plus y is equal to 0. If we take y common, then it is d square plus 1 into y is equal to 0. So this is known as the auxiliary equation. So auxiliary equation is d square plus 1 is equal to 0. If we transfer this plus on the other side, it will become minus 1. And we know that minus 1 is nothing but what? It is I square. So we are getting the complex roots over here. So t is equal to plus or minus I. Now this can also be written as 0 plus or minus I into 1. So alpha, the value of alpha is 0 and value of beta is what? It is 1. So alpha is 0 and beta is 1. Now whenever we are having this complex root, the general solution is given by e raised to alpha x into bracket c1 cos beta x plus c2 sin beta x. Now substitute the value of alpha. Alpha is 0, that value we can substitute over here, and beta is 1, so that value also we can substitute over here. So e raised to 0 is 1, so ultimately we are getting c1 cos x plus c2 sin x as our general solution. Now we'll use these boundary conditions which are our initial conditions which are given over here. What is the first condition is that at x is equal to 0, correct, we are having y is equal to 2. So that value we can substitute over here. So in place of y we can substitute 2, and in place of x we can substitute 0. So therefore 2 is equal to c1 cos 0 plus c2 sin 0, and we know that sin 0 is 0 and cos 0 is 1, and therefore we'll get value of c1 equals to 2. Similarly, using the another boundary condition, the another boundary condition is that at x is equal to pi by 2, y is equal to what? It is minus 2. So that also we can substitute in the general solution. So in place of y we are having minus 2, and in place of x we are having pi by 2. So in place of y it is minus 2, and in place of x it is pi by 2. Now we know that cos 90 degree is 0 and sin 90 is 1. So therefore it is c1 into 0 plus c2 into 1. We can say that value of c2 is minus 2. So in this way we are having the two conditions, and we have obtained the two constants c1 and c2. We can substitute the values of this constant in the general solution. So value of c1 is 2, so it is 2 cos x, and value of c2 is minus 2, so it is minus 2 sin x. So this is the solution for the given particular differential equation, and we can obtain the plot of this particular differential equation as shown over here.